Simon Beard from Cambridge. He's a Quaker too.
Yes, I'm a Quaker too. And thank you very much to Cherry and to QCOP for inviting me to give this talk. And I give this with some unease because I am aware that lots of people who are interested in population are, to my mind, interested in just one aspect of population, interested in population size and quantitative aspects of population. I'm very interested in that, but that's not the only thing that is of interest to me. I am interested in many different aspects of human demography, and I actually work at something called the Centre for the Study of Existential Risk, which is an interdisciplinary institute at the University of Cambridge, whose chief aim is human survival. We take seriously the possibility that humanity faces multiple threats to not only our continuing of our civilization and society and our ecology flourishing in the 21st century, but actually to our species as a whole. And when you start looking in that, you realize that demography has a huge role to play in that. So one of the things that I think QCOP is obviously very interested in is the issue of overpopulation. That increasing population numbers is leading us to do damage to some of our cultural, political, economic, social institutions, but also especially to the ecology that supports us and to our ability to feed ourselves. But also at the Centre for the Study of Existential Risk, we are worried about underpopulation, in particular radical underpopulation. The possibility there might be no humans at all in 2100, which various people have tried to estimate what the risk of this is, and it's very difficult, and arguably there are no sort of really robust ways of working it out, but certainly people have said it could be as high as 20%, and we were founded in part by Martin Rees, current Astronomer Royal and very important physicist at Cambridge, who said he put the estimate about 50%. So there is a huge amount going on here. And one of the things that I always do in my work is to say, might things be a little bit more complicated? Is there a little bit more detail? Is there a little more systematicity, second order effects? Is there any more emergent properties or other sort of just basically complexity, qualitative features, not just trying to simplify everything and boil it down? And that's very much going to be at the heart of this talk. So I hope that QCOP are going to be happy for having invited me, but you're going to hear many different kinds of messages here, and I have many different things to say. But before I say any of the sort of big scientific things I feel qualified to say, I was really glad to be invited here because I work as a scientific researcher at a secular university. And yet I am a Quaker, and I cannot help but see my research and the subject of my research, including human population, through my Quakerism and my religious insight. And it's very hard, I feel, to address that adequately within a university setting and a research setting. And I really hope you don't mind if I just say a little bit at the beginning about the first of these things before I talk about population and the future of humanity. Because I think quite rightly religion has been viewed as having no license to talk about population. A lot of very bad things have been said by religious leaders and in religious texts about population. And this goes back to a very bad time in human history where population meant military might, meant military victory, and military victory was the primary means by which a religion would gain dominance. So the most pro-population, the most pro-war religions often tended to outcompete other religions which held different views. And I know this isn't universal, but this is certainly something that I feel very deeply in the Christian heritage that led to Quakers. And this is problematic in many different ways. Firstly, because it sees human population as of only instrumental value. It's valuable because it serves the interests of the religion or of the state army or whatever. Whereas, well, I'll get on to the whereas a bit later. But firstly on that. And secondly, because actually when you look at demography, if everyone tries to do the same thing, if everyone tries to obey the law, whatever that law may be, this will lead to disaster. If everyone is constantly trying to have as many children as possible, this will biologically have to lead to overpopulation. But if everyone tries to stop having children or only has one child, this will quite quickly lead to stagnation and decline. And even if we said, okay, what people need to do is they need to equalize the population, we need to have one in, one out sort of situation, that also is actually very problematic because human population responds to many different drivers in the world around us, and it responds dynamically. And we can't try and hold the human population in stasis. That is not the sort of response that we need. What we need to do is we need to check the excesses of demographic change and demographic stability. And that's actually almost certainly going to be best achieved if we have at least some degree of diversity. So you cannot have a religious viewpoint that says this is the answer to how many children you should have. And now, where does Quakerism come into this? Well, I think, almost unique among religions that I'm aware of, Quakers, celebrate life very much for its intrinsic value. We don't take the view that just because one life is good, therefore many lives must be better. But we do very much cherish the human race, the future of our species, the planet we live on, and all the creative life that comes from this. But also, Quakers are a very diverse group. If Quakers were to speak with one voice about population, that voice would still say and encompass many different things. We could not impose a one-size-fits-all rule onto a Quaker view of population and demography. And to my mind, that is so liberating and so important. And sometimes I really just want to celebrate that for a bit, that I come from a background and from a spiritual tradition that can encompass and embrace so many of the things that other religions have got wrong about demography. And it's just wonderful to have a space where I can say that, because it's a hard thing to say sometimes. That yes, this is something that I study in a secular university from a scientific perspective, but it is also something about which I feel a great religious commitment. And I think that the celebration of human life and the cherishing and preservation of our species are very important goals for Friends. And I think that when we think about population, we need to bear that in mind. Now, having said all that, and that's important, and I originally did think I might just talk about those things and just talk about Quakers, but hey, I can't resist a few good charts. So I've also started to look at some of the things that I might say, given that that's my background and given that that's the world as I see it from a scientific perspective. So population matters, and if you have looked much at population, you've probably seen a nice graph like this. This is a hockey stick of population, showing how population growth has changed since 1500 and how it's projected to change in the next 100-odd years. And what you will see is this huge, dramatic growth, especially throughout the 20th century. And this has had world-changing implications. The global population has gone from 1 billion in 1800 to now it's 7.6 billion, so when we're rounding, we're now talking about a global population of 8 billion. To have increased population size eightfold in 200 years, that's in 3 lifespans of human life, is just a dramatic change for us and for the world we live in. And this has some implications that I think are incredibly uncanny almost when you think about them. So one of them is it's now the case that somewhere around 8 or 9% of all the human beings who have ever lived are alive today. And given that human life expectancy is also now about twice what it is, that means about 17% of all human experience is being had by people who are alive today. 17% of all the emotions we've ever felt, of everything we've ever known, of everything we've ever seen or heard or felt or touched, is happening with people who are here alive today. And I had a colleague, Julius, who asked me, I know all these things about why we're living in an exceptional time, considered relative to the past, but is there anything that's true about humanity that means that now is a unique time in human history relative to both the past and the future? And I think that this is it. That we are at the very, very peak of our species, of coexisting. We are a young species. We have not been around for that long. We are still on an upward trajectory. And we are having to share and get along with such a variety of human experience. You could go out and talk to people now living who will have almost a fifth of all the experiences that humans have ever had. This is mind-blowing stuff. And it has, sometimes when you link it to sort of more modern things, it has some other really weird implications. It means that somewhere between 1% and 2% of all the time that humans have ever been alive, we have spent watching television. it also means, which actually in some ways is even more dangerous, that 90% of all the scientific research that has ever been done and technological development that is being done has been done by living scientists. If you went to school and were taught science about dead scientists, if you were only taught about Newton and Darwin and Einstein, there was a huge bias in your syllabus. Most of what we're learning about the world and how we're trying to change it, 90% of that is happening all at the same time. You can't build, you can't stand on the shoulders of giants anymore. If you're engaged in scientific research and technological development, you are part of the great mass of everyone trying desperately to cooperate and to coordinate our actions. And I think that's why we now have so many convergent risks and so many rapid changes going on at the same time, whether that be in computing, whether that be in biosciences, whether that be in industrial technology. All these things are happening at once. And we're having to try and respond to all these problems without the luxury of saying, well, what did the last people say? And do we agree with that? Were they right? We're just having to try and make it up as we go along as a species. So this is a really important graph. But as a scientist, I have a problem with it. It's on a linear scale. It should be on a logarithmic scale. So this is the same data. But this time, I don't know if you can see the little lines, but rather than each point on the axis being another, I think it was 2 billion last time? Yes, rather than it being 2 billion. These are each now doublings. So every line, every point on that scale is now a doubling. Now why is this more appropriate? Well, because whenever you're trying to represent numbers that aren't bounded on the top or the bottom, you need to take these linear effects into play, because if you have more people and you have a growing population, that growth will just always lead to more and more numbers. So you can generate things that look like a hockey stick, like the one we saw in the previous slide, where there's actually only linear changes going on. But what we see here is that that's not true. That the expansion that we had in the last 100 years is truly exceptional. The human population doubled twice in a little less than a century. Its fastest doubling took less than 40 years in between the early 50s and about 1990. Another thing you see, though, and I do think that this is important, is on the previous graph, you kind of get the impression that nothing's really happening here. These 1500s, 1600s, 1700s. Actually, that's not true. You had population growth, you had doubling of the population all through this. And this period actually is an artificially flattened part of the graph, because human population underwent 3 great big disasters between about 1300 and 1800. The first of these affected Eurasia, and were typified by the end of the late medieval warming period, which saw a huge famine at the beginning of the 14th century, and then the Black Death, and at the same time the Mongol hordes. And together those 3 things killed well in excess of 100 million people, at a time when the global population was probably only about 500 million. Then at the beginning of the 15th century, and this actually, you can start to see the effects of this here, there is a real flattening, because of the discovery and colonization and rape of the Americas. That Europe discovered America and saw it as a completely empty wilderness, and infected it with diseases and colonized it with slaves. And in doing so, probably killed upwards of another 100 million people. And this has an effect. And then the third tragedy was obviously the tragedy that hit Africa, which had endured terrible slavery for much of African history, but that was really accelerated then by the need to get the slaves to populate this empty space we created. And these actually produced a considerable flattening of the population growth, which then, with industrialization, you see this takeoff. Now, the other thing, when you look at this and when you realize that even with all these disasters going on, there was continuous growth. I've spoken to demographers who reckon that despite everything that was going on, probably the global population was still growing every year for these times. It just less than expected. You then look at the top here, and I think in a slightly new light. Because again, when we look at it before, it looks like this is more or less a return to what we had before, that this was an exception, but we had something before and we're going to something new. But when you represent them more accurately on a logarithmic scale, you see that this is actually flatter, even than these great disaster years in the middle of the second millennium AD. And that's something that we're heading for. We are currently living in a period of higher population growth than the world has ever seen. But probably within another lifespan or 2 lifespans, we're going to live in a world with lower population growth than we've ever seen. Now, it's really important to say at this point, quite right, we need that. I'm not saying that's a bad thing, but that is going to be another amazing, bizarre experiment in human history that I am expecting to have to start engaging with in my lifetime. And population matters. This drives so much of what goes on in our lives. One more way that I think it's really important to look at these lines. This is a global population pyramid. So this is expressing the global population in 1950, 1960, 1970, 1980, 1990s. This is 2018, this line between the green and the blue. And this is in the future. This is up to 2050, 2075, and the top one is up to 2000. And to me, the really interesting line is the 1990 line. So 1950 to 1990 was this fastest ever doubling of the world's population. And almost certainly the fastest that it ever will experience. And what you see when you compare this dark blue line to this line, which is rather harder to see but goes like that, is it did this, right? It was almost all of the growth was in the youngest generations, and the biggest growth was in births, was in the width of this line at the bottom. Look at this, 1990 is here, 2050 is there, 2100 is actually back there again. The growth that we will see, and we will continue to see growth, well, we've already seen a lot of growth from 1990 to now, and we'll continue to see growth up until the 20th century. It's not like that. It's all like this. It's all this uplift. There's people living longer. Population growth has been a matter of fertility for a long time. And it's really important that we get that under control, and we continue getting under that control, and we make sure that we don't go beyond this 1990-2018 line, because this would be very dangerous for many, many reasons. But we do have all these extra people who are still being added, even if we get the fertility right, even if we stay at replacement level. And really, when you get to 2100 and it looks like this, how do you know? How do you know what people's lifespans are going to be in 2100? That's actually a much harder thing to predict. We don't know what medicine's going to happen. I have friends, people who work in my field, who think we're going to be living forever by 2100. That would just be, woo, right off the scale. This thing would explode. We'd be going back to population increase like we've never ever seen, because just keep on adding people at the bottom and it just keeps on rising up. But problem is, this isn't for fertility. We find it hard to talk about fertility, but actually fertility is usually the easier part of the demographic scissors to talk about. This is all mortality. And that is a good thing, that mortality is declining and people are living longer. So what do we do? What do we do? I don't know. So this is the message from my talk. Population matters, but maybe not always in the way that you think. I don't have any direct, simple answers to the ethics of this demographic situation I set up. Maybe some of you do. I'd be very interested to hear them. And I think that there are some things we can do, but the whole enormity of the challenge is ginormous, even for Cambridge researchers to deal with. I do, however, really want to talk about now one aspect of the population effect, and I think it's probably the one that's of most interest to people in this room, which is the impact that human populations are having on the environment. And this is also one of these. Population matters, but not always in the way that you think. So this is a chart from the Royal Society, did a wonderful report on population and the planet, in which they just put together as much of the sort of evidence of what's going on with global population change and the impact that that's having on our ecology and the policy options for dealing with it, without really making any kind of judgment calls. And I think it was a really great piece of research synthesis. But this was a chart that really, really leapt out at me as showing just how complicated this is. So this is a chart that shows the percentage of different ecosystems where we've removed the natural ecology and basically how much of that ecosystem we purpose to meet human needs. So these three on the far left, these are the ecosystems roughly where we live. These are the temperate and Mediterranean ecosystems. Here we have the tropical ecosystems, particularly the rainforest. Here we have more inaccessible ecosystems, deserts, mountains, and more swampy terrain, harder to get to. And right here on the edge where we hardly touched it, this is cold. These are the tundra and the boreal forests. And some of these are really heavily used. We're really pushing up, currently at 80%, pushing towards 100%. And this is a big, big problem for the ecosystem. But this chart shows three colours, which is when this change happened. So the blue line shows all the changes that happened up to 1950. The red line shows all the changes that happened between 1950 and 1990. And the yellow bar, with its error bars at the end, shows the changes that are expected or have already happened and everything that's going to happen up to 2050. So from 1990 to 2050. And this shows, I think, two really important and really contrasting things. The first is the effect that we're having on the environment, and it is huge. And so much of the environments that are accessible to us, we've already changed to serving our direct interests. They're doing nothing, to support the natural ecosystems that support us in many other ways. This is just what we completely sort of wiped out. But also, you do see, well, the blues are the biggest in every ecosystem, and often they're by far the biggest. And these red bars, this was the fastest doubling of the Earth's population in human history, happened in these red bars. And in almost all of these, yes, it made it worse. It made a bad situation worse, but it didn't double our impact. It didn't double the amount of space we need. One of the reasons for this, and especially at this end, especially at the European and Mediterranean and some of the more accessible tropical ends of the spectrum, the reason for this is, actually a lot of this change is prehistoric. We had a huge impact, Homo sapiens had a huge impact on the environment before we invented agriculture. Human hunter-gatherers wiped out almost every large species that was bigger than us, on almost every continent on Earth, except for those who evolved with us in Central Africa, and those who we then later were able to domesticate to our own purposes. So we keep the cows, keep the deer, to some extent we keep the goats, to some extent we keep the deer and things. We keep the elephants, we keep the giraffes, but the woolly mammoths, they went. The dingoes, not the dingoes, the Tasmanian devils, all of these the world used to be full of megafauna. Animals that would dwarf human beings. They all went, before we invented agriculture, they all went when human beings were maybe 500,000, 1 million people. Because of the way that we hunted, we had some extremely ineffective means of hunting. One of them was we hunted with fire. When we invented fire, we set light to habitats, and you caught everything that ran out, or everything that you could that ran out. And you could get a lot of animals that way, but you probably caught 0.5% each. This is really complex. Some changes are really old. And there's a mentality sometimes when we talk about population, a sort of Garden of Eden mentality, that humans used to live in balance with nature and now we don't. And actually, yes, sometimes we did achieve equilibrium with the natural environment, and that was great. But we were also really, really good at destroying the Earth before we got so big. Some changes, though, are really new. Just mind-bogglingly new. This graph shows what percentage of all carbon dioxide emissions happened in your life depending on your age. Now I'm 34, so I'm, which one am I? I'm about here. Well in excess of 50% of all the carbon dioxide emissions that have ever been emitted by our species has happened in my lifetime. My daughter is 7, and more than 10% of all the carbon dioxide that we've ever emitted has been in her lifetime. Global warming has been the product of 1 or at most 2 generations. It is not a problem that we've been trying to deal with since the Victorians. It is not a problem of industrialization. It is a problem of just how huge our global economy is. And a ginormous part of that has been population growth. There have been other things going on, I'm going to talk about that. But this, population growth, and especially in China and India, and the development of, the economic development in those countries, it's just, I see the school strikers and so on. And it's just, you're already on a point in a situation where maybe 20% carbon dioxide emissions have been emitted in your lifetime. That's so scary. What's going to happen in the next 50 years? Thank God these kids are willing to step up to the mark and take some responsibility. We cannot go on like this. And just also, it's worth pointing out that over 50% of the carbon dioxide emissions have happened since Kyoto, since we started having international agreements on cutting this. So, there's lots of things. Some things clearly are recent and relate to recent demographic changes, others don't. How can we make sense of this? One really useful tool is this, which is the Global Footprint Network. This tries to put together all sorts of different effects that we're having on the biosphere, including climate change, including habitat loss, including all sorts of things. And it measures it in terms of the number of Earths that we would need to service our current needs. And this shows how, as late as the early 70s, we were doing okay. We were less than 1 Earth. Then we needed everything in Earth to meet our needs. And now, because, well, we'll see all the things that are driving this, or the one thing that's driving this, but it's gone up and up and up. So we're now at this 1.7 Earths. This is completely unsustainable. It has gone down very slightly in recent years. It's more that it's fluctuating, and I've smoothed the graph a bit, so it looks like it's gone down. But it's leveling off. It has done in the past. But that is irrelevant. Anything above 1 Earth is a huge problem for our future. And you show this graph and you talk about population, and what you will hear people saying all the time is, no, this isn't a population graph, this is a consumption graph. This is about the economic growth we've had. That's what's causing us to be so unsustainable. So my next graph is the proof of why that is completely false. This blue line here is the Earth's. This is what we saw on the last line. This green line here is the population growth from our first chart. And as we see, that tracks reasonably closely. I'm trying to set them equal to 1 at the same point. This red line is the economic growth, right? And again, this is on a logarithmic scale. So this isn't kind of 3 points above. This is 8 times higher. The growth in the global economy compared to the growth in our need for resources. We've actually been able to achieve all sorts of benefits in quality of life without significantly increasing our individual impact on the environment since the early 60s. If we hadn't have had this population growth, this would still be at 0.7. This would not be at 1.7. That is a simple econometric fact. If you strip out the population growth, this is what this graph does, and this is from the Global Footprint Network of the global hectares per person. You see that it's gone up a bit, it's gone down a bit, but basically it has stayed the same. The amount of the Earth that each of us is requiring. It is only because of the population growth that we're in this huge mess when you add everything up. This graph also shows, and this again is data from the Global Footprint Network, how on earth this is even possible. This sounds like some kind of magic, given the standard of living and the various other things we've achieved. What you can see is these bottom two ones, which is our need for forest products and our need for grazing lands. These have actually declined, our individual needs for these two things. They've declined quite markedly. Our needs for fishing grounds, for land to build on, and for farmland generally have stayed pretty much the same throughout these times. But our need for carbon sinks and offsets and this voracious appetite we have to burn fossil fuels, this is what has pushed us up. This is really the only thing that we're getting very, very wrong. Otherwise, well, this and population growth. I mean, if it wasn't for this, we'd have a shrinking footprint. And if it wasn't for population growth, this pattern would be completely sustainable. Okay, that's kind of some of the problems. I want to now just talk through a couple of what I think is going on here, how this is even possible, that despite the quality of life improvements, this rampant economic development, for good or bad, that we've seen, and some improvements in longevity and healthcare and so on, why this is actually evened out over all of these different considerations. One of them is the simple fact that all these people that we're adding, unfortunately, are being predominantly added amongst the poorest, who predominantly have the smallest impact. And so on average, what we see is the impact per person isn't changing very much. So this graph shows where people have kind of been added on the income spectrum. And I just picked this graph because it was striking and I didn't know how to make one of my own. It's not well suited to the time frames I'm talking about. But this graph here shows 1800. All the different continents, this is Asia, is in the red, Europe is in the yellow, Africa is in the blue, and the Oceania, the Pacific regions in the green. Everyone's more or less in the same boat at 1800. And then what you get by 1975, you get a few developed countries led by European countries are pulling ahead. By 2015, actually, these countries are more or less where they are. Now, this is also on a logarithmic scale because this is a well-drawn scientific graph. So there has been growth in this, but it's not been a sort of huge doubling or tripling because this is the average. All the big movement has happened right down here in this little snap you can't even see. I'm a researcher. I'm earning about $140 a day. That would put me right here. Suspect most Quakers would fall somewhere here as well. We really haven't changed all that much. What has happened here is this huge grabbing of wealth by the people you can't even see because they're way out here. That's happened, but that's not a demographic change. Most of the people have obviously been added in developing countries. This huge spike in Asia and a huge growth, even though it's not so big on relative terms in Africa. And that means that the average person now still looks poor, even though there are a lot of rich people doing a lot of damage.
Could you explain to me 1975?
Yeah.
The Africa, that huge raise and then the dip.
So this is Asia. So this is largely the income distribution in China and India, and which already had huge populations. The population of Africa is still quite small.
So it's the shape of the Asian.
It's the shape of the Asian curve, so basically Asia is still predominantly very poor. Europe is still predominantly very rich, and these are still two very big areas of population concentration. So that's why you get this bimodal distribution, these two peaks. Whereas here, because Europe hasn't moved so much and Asia has moved a lot, the whole thing kind of homogenizes again. And all these people added in the middle, but still to the poor end of the spectrum. Another important thing that has happened is urbanization. Cities are efficient. We don't like them in many ways, but cities allow us to share all sorts of things that are very hard to share in the countryside. We share heat, we share light, we share public transport. Cities also make it easier to recycle things at a municipal level. And yeah, from a demographic perspective, blocks of flats actually look, sorry, not from an ecological perspective, blocks of flats look pretty good. You get a lot of people all together. They're all kind of messing in their own backyards, and that's a problem for the people, but for the planet, it's quite nice. And what we've seen here is big, again, this is a long run trends, constantly upwards in urbanization, especially in China, but pretty much everywhere is seeing continuous urban growth, which is quite impressive given that cities don't generate people. It's the countryside where people are born. Cities kill people, especially in developing countries because of the air pollution, the road traffic accidents, the diseases that come with living close together with each other. When you see upward rises, long-term increases in urbanization, this really underplays the movement of people from a rural to an urban environment all over the world. And that, yes, that decreases the demand for things like forest products and grazing and so on. And it means that, and again, this is one of these big double-edged swords, but it means that the people who are left in the countryside either stop farming and the farmland goes back to natural environments, or they get bought out and it gets intensified. And intensive farming, again, has many problems. It's not all great for the environment by any means, but it does allow you to produce a lot more on less land. The third root cause I do want to get into a little bit, although this is a lot harder, is the question of technology. Technological development has allowed us to have more whilst doing less damage. It's also allowed us to do more damage, but it does allow us to have more whilst doing less. And I think, again, looking at it from a population perspective, there are some trends that are particularly important. One of them is that technology is what allows people to live together, to live in close proximity in these more efficient urban units without killing each other. You can have much more efficient engines in your cars, you can tackle air pollution, you can improve public health and sanitation, you can make the built environment better. You may not do all of those things, but it allows and is feeding this great expansion of urbanization. And it is also allowing us to do more with the land that we have. It's increasing intensification, it's increasing crop yields, it's doing huge, the Green Revolution really helped India's ability to feed itself. It has done terrible things to Indian farmers and their economic position in the world, but from a purely demographic perspective, it really has been a miracle. And that's, again, I wish I had more simple things and less sort of, here's something more complicated, here's something that comes down on both sides. But I do think it's important, and I don't know those of you who are around in 1968 and Paul Ehrlich's The Population Bomb, and this equation that's become very important amongst population campaigners, IPAT, impact is a function of the population, the level of consumption, the level of technology. Actually, I've been arguing here, population really has been the driver of much of our ecological destruction over the last 50 years, because the technology and consumption do seem to have held in balance, albeit I think there's a lot of important demographic as well as kind of technology in the sense that we usually imagine people in labs and robots. But there's a lot of it going on. Okay, now for the hard slide. Now for the slide I wish I didn't have to write. I could just give you, I've done the spiritual bit, I've done the flashy charts. This is the slide about what can friends say, what can we do. The first thing, I think Quakers can and should talk about population. Cherry was asking me, what do I think that politicians should do about population? I said, well, at the moment I'm quite skeptical about politicians coming in and saying, I'm going to cut the birth rate, or I'm going to increase the mortality rate with my special Brexit. But that's not going to cut it. But there are groups where we can be courageous and we can talk about these things, even though they're hard and even though they don't have easy solutions. And friends are good at this, and we are loving and caring, and we are surprisingly knowledgeable. And I think one of the things that friends have done in many different ways is to be a lab in which actually quite ordinary people and experts and everyone in between can get together and talk about these hard issues. And I really want us to carry on having that conversation, and I really want to have that conversation and be welcomed to give my, I'm not sure one or the other, but it's complicated kind of line, because I think these are hard and we should talk. We shouldn't just listen. Although that's also important. Then I think two other things. I think we need to have the humanity to recognize what those countries that are going through this demographic transition faster than ever before. The UK, our demographic transition, our transition from being a high fertility, high mortality society to a low mortality, low mortality society took about 200 years. The countries that are going through it now, they're doing it in maybe a generation, 30 years. I'm talking particularly about South and Southeast Asia. And the countries that are just entering into this, particularly in sub-Saharan Africa, all the kind of historical trends suggest that they are going to go through it even faster. And it's hard. It harms people. Having a situation where in your mother's lifetime everyone belonged to a big family who all cared for each other and who all knew their place and all brought up each other's children, to maybe the grandchild is growing old in a flat with no one to take care of them because they haven't had any children of their own, and maybe they don't have any brothers or sisters either. That is really hard, and many of these countries are going to go through that transition without the benefits that we've had. The UK sent huge waves of population off to colonise the rest of the world. We are not allowing other countries to do nearly so much emigration. And we also had huge and ongoing economic growth, which again, these countries are not going to have at the same level.
Excuse me, I think number 2 should say demographic.
What
did it say?
It says democratic.
Oh, I'm sorry, it should say demographic transition. Oh, yeah, I'm terribly dyslexic. Yes, demographic transition, you're quite right. And the other thing, and I think again this is something that the Quakers are quite good at, is we need to have the courage to accept that our society is going to carry on changing. That demography never stands still. It is about diversity. It is about people changing and moving, and people will change and move here. We will continue to be an aging society. Young people will continue to be a smaller and smaller proportion of our society as a whole. We will continue to diversify ethnically, linguistically, culturally. In particular, we are going to be we're going to Africanize. We're going to have many more people from our very close neighbours who are just denied the economic chances that we are here in Europe, who quite naturally seek that, and who probably, given climate change, have no choice. And Friends have been at the forefront of doing this. But welcoming change and accepting that quite possibly the best thing from both an environmental and economic and a social perspective is going to be to try and seek more change rather than less, is a very courageous and a very difficult thing to do. And I think, again, this is something where Friends have the opportunity and have already stepped up to lead the way, and where I hope that we're going to carry on doing more. So that's it. Thank you.
Thank you.
I know we're not supposed to applaud, and I don't know about you, I feel like cheering. It's absolutely amazing, Simon. Thank you so much. What a fascinating talk. I think we have 5 minutes or 6 minutes if there are any questions. Yes?
Quite a specific question, but I'm aware that young women in the UK and the US and in the affluent world are starting to think that they shouldn't have children because of climate change. I wondered if you have a view on that, any comments on it?
Yeah. I mean, there's lots of different shouldn't have children. There's lots of different attitudes and emotions that are going on here. And one of the difficulties that these people are having is there's very little space. I have colleagues who are going through this, and even in an existential risk research community, there's very little space to talk about this and not feel judged. There are people who don't want to have children because they're scared of climate change and the lives that their children will have. And there are people who don't want to have children because they know of the environmental impact that their children will have. And one of these is a very positive decision, and the other is, at least emotionally, a kind of very negative decision. And I think these are both very legitimate concerns. But as I said at the beginning, you can't have a one-size-fits-all policy in demography. If everyone took that decision, which they're not going to, but if they did, that would also be problematic. And I think at the same time you are also seeing people, as I was saying, a copy kind of choosing to have big families, and if you look at it, one of the reasons for that is it's a natural human response to insecurity to have big families. This is a very biological impulse. It's something you see in many different species, not only in humans, and it's something you see in historical demography as well. And I think that we are making young people scared. They're scared economically because they don't have security. They're scared socially because of all the changes that are going on, and they're scared ecologically. And unfortunately, there is, the flip side is some people think about that and think I won't have kids, and some people don't think about that but react to it in quite an instinctive, emotional way, and they have more kids. So I think that the more that we can give people space to talk about their fears and accept them and not say, oh well, that wouldn't work for me, or that's not the choice that I want to make, or that sounds a bit weird, the better, because we all have fears.
Seems to me, given that fertility seems to be falling, or at the moment is falling slightly, the big problem is us old people. And if we're going to live, my father's just died at 98. I'm older than most of his siblings were when they died. So if we're going to go on like this, maybe we shouldn't be striving so hard to achieve a longer lifespan.
Yeah, I mean, it is where the demographic momentum is coming from at the moment, and a lot of the benefits of lower mortality you wouldn't want to get rid of. Actually, the big change is the drop in infant mortality and mortality amongst young people. It's always been the case that kind of if you get to 15, you're very likely to make it to 45, even 50 or 60. So low life expectancy countries, a huge part of that is infant mortality, which no one would wish, I think. But now that we have a situation where global life expectancy is over 70, all around the world, that's the average person can expect to live to 70. And we don't have nearly so much, I think, investment in quality of life. You know, it is all about fighting the diseases of old age and prolonging life, and you know, that money could go a lot further in palliative care and in rehabilitation and in mental health and all these other things that can do a lot of quality of life, but that don't make so much money for the drug companies. And it's a problem, and no one wants to say, yeah, I'm pro-mortality, but I think it is an important point, and I think it's something that, you know, if we're brave, we can say sometimes.
I remember Jeffrey Durham saying that the real problem is that we older people are living beyond our die-by date.
Any more burning questions? Yes, go ahead.
Hi, I'm just wondering with your point 3, for the Quakers, it may be better if it changes more. Our society changes more than if it changes less. Could you give us some specific examples of kind of what you mean?
Yeah, so I definitely mean, and I'm thinking about this particularly demographically, so I definitely mean if we have more immigration rather than less immigration. The UK is a liberal democracy that does still stand up for the rights of minorities and is still seeking to empower people. We have a very efficient infrastructure energy-wide. That's sort of the only reason that we managed to do anything about our climate commitments, not because we've had behaviour change or policy change. It's a good place for people to live. And one of the things I particularly had in mind here is you hear people who move from the global population issue to, oh, that means, you know, England must be overpopulated. And I think that's a very dangerous idea. I think we need to be welcoming to people and to a diversity of people, and we need to you know, accept everything they have to bring. It's also about urbanization. I live in Cambridgeshire, which is a very rapidly growing urban area. It was kind of weird when we decided to have a single mayor for Cambridgeshire. Surely cities have mayors. But actually, when you look at the direction that Cambridgeshire is going, it is integrating as one large city, with Cambridge in one corner, St Ives and Huntingdon in another corner, Ely in another corner, and Peterborough at the top. And actually, I think there are significant potential to grow in a very green way if we do this, if we allow this to happen. But it's very scary living in a nice little village outside. I want to see, it's not psychologically pleasing. It kind of interferes with my liberal values, but that nevertheless may still actually be a better way for the human population to live than for us all to be in nice little villages surrounded by fields.